Welcome to the Backyard Professor Math videos. It's a beautiful day. I'm trying to make it so that my board is clear so that you can see it, but it reflects stuff. I can't help it. I'm outside in my backyard. The study of math is coming along really good. I just want you to know we're making good progress. We're to the point in our algebra studies to where we are going to have a major breakthrough, I would say within the next 6 to 8 videos. And we are going to learn enough different types of operations with various kinds of equations that we're going to lose our fear, as it were, our intimidation, our concern about mathematics, about algebra specifically. We're going to open up an entire new huge area of studies in algebra that's going to be very, very helpful. So I'm excited about the next, say, dozen videos. In the meantime, we're going to keep practicing the various kinds of videos, the various kinds of equations, I should say, and expressions. Now, one of the most powerful tools in all of algebra, because it helps us solve equations that sometimes get pretty doggone difficult, they help us solve them easily. And this is the idea of the reciprocal. The question is, how do we turn 1/2 into 1? How can we make 1/2 into 1? We do it by taking the reciprocal. That is the opposite of it. What is the reciprocal of 1/2? In order to turn a fraction into the number 1, we need to make this equal on top and equal on bottom on the denominator in a fraction. So we multiply 1/2 times 2. Now, any number, it doesn't matter whether it's a negative integer, it doesn't matter if it's one of the natural numbers, any number multiplied over itself equals 1. And any natural number is a fraction. We just simply put 1 over it. We're not changing the value or the meaning of the number 2 by making it into a fraction. Why? Because we can always take the denominator and divide it right back into the numerator to get back our 2. 1 goes into 2 twice, right? When we take the reciprocal of a fraction, then we multiply straight across the denominator and the numerator. So 2 times 1 is 2, 2 times 1 is 2, and any number over itself in a fraction is simply 1. When we need to simplify expressions, the reciprocals, taking the reciprocals, can be very helpful, and we're getting to the point where we're going to begin studying slope line formulas, and we're going to start learning how to graph equations and functions on the Cartesian coordinate system. This comes in extremely handy. So I want to just show you the idea here. -3/4. How do we turn that into 1? We flip the fraction over. Keep the sign, keep the negative sign, but we multiply this by -4/3. We turn it upside down, then we multiply straight across. -3 times 4 is -12. 4 times -3 is -12. A negative divided by a negative is a positive, and that becomes 1. This works for virtually every fraction under the sun. 9/16, we multiply by 16/9, and 16 times 9, 1849, over 1849, and any number over itself in the numerator and the denominator is always equal to 1. It's that easy. Oh, it's not 1849, but it's 144, sorry. I gave you the wrong number. It doesn't matter. It equaled 1. Any fraction whatsoever divided by the numerator, if you have a double negative fraction, -6 over -11, you can multiply it retaining the same signs by its reciprocal. So this is going to be negative 11 over 6 over negative 6. And a negative times a negative is a positive, and a negative times a negative is a positive, and 66 over 66 is 1. It's that simple. Now you can see the same thing if it's positive times 11 over 6. It doesn't matter if the signs are negative or positive. By taking the reciprocal of any fraction, you get to that number 1. This is an important principle I just want to introduce you to make sure you understand this. This is simply going to be positive 66 over positive 66, which is simply 1. 1/3. 1/3. You multiply it by 3, and that turns that fraction into the number 1. Any number is a fraction. You simply put a 1 under it and then multiply straight across numerator and denominator. 3 times 1 is 3 3/3, which equals 1. This is going to be a very useful principle to show us. Now, it's going to help us immensely in solving some linear equations, because we will begin dealing with fractions heavily with linear equations, and we just want to be familiar with it, comfortable with it, so that we can see this. What if we have the number 5 3/4? What if we have a mixed number? Can we turn this into a number 1? Absolutely we can. What's the first step you do? You make it into an improper fraction. 4 times 5 is 20, plus 3 is 23, and you retain the denominator. Now you simply multiply 23/4 by its reciprocal, times 4 20/3, and that's going to be 92 over 92, which equals 1. If I've done my math right. Oh, 94, sorry. Well, 92. That's how reciprocals work. Now let me show you another fantastically interesting concept here. In line with the idea of reciprocals and taking the opposites to turn a number into 1 and working with fractions, we have 3 to the first power. What does that equal? That simply equals 3, right? 4 to the first power equals 4. 5 to the first power equals 5. Why is that? Because every one of these numbers multiplied by itself by 1, because the exponent tells you how many times you're going to multiply this base number. That's why 3 squared is not 3 times 2. This tells you to multiply 3 by itself twice. So this is 3 times 3, which is 9. 4 squared is 4 times 4, so on and so forth. We've been over this, but I want to show you a new idea here, or a more expanded idea, as it were. What if we were given, instead of 3 to the first, what if we were given 3 to the negative first? What happens when we're given a negative exponent as opposed to a positive exponent? These will begin coming up very, very often in, well, mostly in calculus, but in algebra a lot too. What does this tell us? This is the same thing as the fraction 3 over 1, which is just 3, remember, to the first. To the negative first, sorry. This number, 3 to the negative 1, and this fractional aspect of the number, whole number 3, as 3 over 1 to the negative 1, these two are equivalent expressions. They tell us the same thing. So when we raise a fraction to a negative exponent, the idea here, especially to the negative 1 power, is the same as taking the reciprocal of the fraction. So what this means is, in simple language, 3 to the negative 1 equals 1/3. We take the 3 over 1 and we flip it over to 1/3. We take the reciprocal whenever we have a negative 1 exponent. And this is a very important piece of information to understand. 2 to the negative 1 simply equals 1/2. 4 to the negative 1 equals 1/4. And so on and so forth. So that you can see that a number raised to a negative exponent power, the reciprocal of this number is the fraction with that number in the denominator every time. This is kind of really cool to know. Let me show you how we know this is the case completely. This little demonstration that I found is really cool. All right, let's have 2 divided by 4. Okay, now the equivalent expression of 2 divided by 4 is going to be 2 divided by 2 to the second power. Would you agree with that? This 2 to the second is the exact same number as 2 to the fourth. It's just written in exponential form. Every number has an exponent. When you don't see the exponent, it's sometimes the invisible exponent. But every number, it doesn't matter if it's 16. 16 itself is 16 to the first. We just don't write the 1 to it. 4 is 4 to the first. 99 is 99 to the first. Every number, no matter how large, no matter how small, negative 33 to the first. It doesn't matter whether it's negative or positive. Every number has an invisible 1 as an exponent. And conversely, every variable does too. It doesn't matter if it's the letter A, C, E, G, M. Every exponent is actually to the first power. That just simply tells us that it is that exponent or that number itself. You don't multiply anything by itself. A squared is going to equal A times A, right? A cubed is going to be A times A times A. Well, A to the 1 is simply itself, A. Okay? So every number has an exponent. This is something we'll want to keep in mind throughout algebra. And the reason why is very interesting. 2 divided by 4 equals 2 over 4. Would you agree with that? I think so. Now, we know the numerator and denominator are both even, so this can be simplified. We divide, we take a 2 out of each side of this, and this equals 2 divided by 2 is 1. 4 divided by 2 is 2. So 2/4 is the exact same equivalent fraction as 1/2. 2 divided by 4 is 1/2. Would you agree with that? You ought to, because it's correct. Watch what happens when we put this in exponent form. 2 to the first divided by 2 to the second. Remember, every number has that exponent whether you see it or not. Well, this just simply equals 2 to the first divided by 2 to the second. But we know when we divide exponents that we subtract the exponents. You remember when we multiply exponents? A to the fourth times A to the fifth. We keep the same base and we add the exponents, A to the ninth. And the reason why is because this has 4 A's, 2, 3, 4, and this has 5 A's, and 4 plus 5 is 9. So we add the exponents when we're multiplying. It makes perfect sense that we subtract the exponents when we are dividing. So this essentially equals 2 to the 1 minus 2 power. And this equals 2 to the negative 1. Right? So we agree that 2 divided by 4, I want to make sure I write this right, equals 1/2. And we agree that 2 divided by 2 squared equals negative 1. 2 to the negative 1, sorry. 2 to the negative 1. These are the same expressions, so this is virtually telling us that the fraction 1/2 is the exact same thing as the number 2 to the negative first power. Those two are equal. They are the same thing. So we're learning that negative exponents and fractions are reciprocals. This is going to be extremely helpful to us in algebra. This is going to be very nice to know. This will simplify linear equations. This will help us simplify all kinds of graphing issues when we go to graph functions and we go to graph equations. Knowing these little ideas, knowing what's opposite of each other in reciprocals, are going to be very, very important. 1/2 equals 2 to the negative 1. This is something you're going to want to understand. If you ever get something in a negative exponent and you need to, you can immediately turn it into a fraction. Especially if some of your other equation on the other side of the equal sign are in fractions, you can convert the whole equation into fractions, and vice versa. If you need everything in exponents, you can put fractions into exponents. This is a fabulous tool, as we will see, I promise. So if 2 to the negative 1 equals 1/2, then 3 to the negative 1 equals 1/3. And 4 to the negative 1 equals 1/4. And so on and so forth all the way out. So 10 to the negative 1 equals 1/10. And when we get into scientific notation, this will become very helpful. What happens when we have 10 to the negative 2? What do we have here? This becomes 1 over 10 to the second, which is the same thing as 1/100th, because 10 squared is 100. So this shows us that if we have 4 to the negative 2 exponent, the positive 2 exponent is going to give us 16, right? But because that's 4 times 4, we multiply 4 twice. But the negative exponent is going to give us 1 over 4 squared. You change the sign because you're putting it in the fraction, in the denominator of the fraction. So 4 to the negative 2 equals 1 over 4 squared. Well, what's 4 squared? 16. This equals 1/16. Notice the difference between the positive exponent is 16 and the negative exponent gives us 1/16. This is a valuable tool to help us learn how to manipulate fractions. What if we have a fraction 3/4 to the negative 1? What happens if instead of a number, a whole number, we have a fraction to the negative 1? This simply says, this gives us the answer as the reciprocal of 3/4. So this answer is going to be 4/3. You're simply going to flip the numerator and denominator around, and that equals 4/3. So 7/8 to the negative 1 equals 8 over 7. You do the reciprocal of the fraction. The reason this is helpful to us is because, remember, everything in math is designed to make things more easy. It really is. I know it's hard to believe sometimes. It's even hard for me to believe sometimes. But all of the operations, all of the rules, all of the procedures, the manipulation, the undoing of everything is designed to simplify our ability to give us the power to solve these equations. Even in fractions, 8/11 to the first power is simply that fraction by itself. 8/11, right? If 8/11 was raised to the second power, what this is going to tell us is this second power distributes itself to the 8 and to the 11th. These two expressions are the same thing. With the parenthesis around the fraction, this is telling us that this exponent applies to both the numerator and denominator. So, these two are equal expressions. And this is just 8 times 8 over 11 times 11, which is simply 64 1/21s. Right? This is what happens with the positive numerators, or I mean exponents. With a 1, you simply have 1. Right? It makes sense. With 2, you have 2. If it was cubed, it would be 3 of these. So it makes sense that 8/11 to the -1 has to be the reciprocal. We have the reciprocal sign as opposed to the regular one. This is a regular 1 exponent. But if we have a negative exponent, we're undoing the positive one. And how do we undo the positive exponent of 1 with the negative 1? What this means is we're going to flip this fraction over. If we put this one with this one, 1, what we have is the negative is going to be the reciprocal, and the positive here is going to be the regular one, and voila, we have 88 over 88, which is simply 1. The reciprocal undoes the regular, I'll put it that way, so that we always end up with 1. Very powerful concept. We will use this for absolutely ever for the rest of math. You got to remember, when we study algebra, we are simply studying simplified calculus. Calculus is just really very advanced algebra. So algebra is simplified calculus. When we jump into trigonometry, for instance, and we start studying triangles, you know, when we start studying trigonometry, we aren't going to just drop off algebra to study trigonometry. No. Algebra is the foundation of how we operate with equations of numbers that is going to carry over into our study of trigonometry. It's also going to work into our study of the calculus. When you take the derivative dy of dx, you can see right now, well, there's a fraction. Absolutely. You're taking a small part of a whole and you're going to split it down infinitely small, and then you're going to add it all up and you're going to put it back together again. This is the idea of integration. It's also the idea of the derivative, finding the tangent line to a slope. There's a regular slope. I didn't do that one very good. in a chart, if we have a function that does something like this, we have a slope, but it's a curve. We want to find at point A right there, the tilt of that curve. We have to bring in a tangent line. That's going to bring in lots of fractions and lots of exponents. So we use what we're learning now in algebra as the basis of calculating even more complex equations later on in trigonometry and in calculus. Which is really great, because if we get the algebra down now, all the rest becomes much easier. So anyway, that's what I wanted to show you. This idea of reciprocals, a very important concept. And I'm going to advance with the next several videos. We're going to work into a very important algebra topic that's going to take a little practice. I'm going to show you step by step, just like I'm always trying to do, because when it was shown to me step by step, I got it. Aha! Oh, this isn't so complex. It's not impossible. You are smart enough to learn algebra and trigonometry and calculus. Maybe the system didn't teach us right, and I've let that stop me for decades. No more. I know I'm smart enough to learn this stuff, and I know you are, so let's do it together and have a ball doing it. So, happy calculating, have a great life, and I'll see you in the next video.